All right. So we're going to do the same thing here. We're going to do the same thing here. All right. Let's start with our line. So on this side, is there anything that's in the same tree? Yes. So we have our 3 and our 7, which gives us 10. And then I'm going to bring down my x. On this side, is there anything in the same tree? Yes. This and this, 2x minus 1x is 1x. And then I'm going to bring down my minus 10. Now it's just like what we did last week. What do we do to both sides? We're going to move this over to here, minusing 1x. That's gone. That's actually gone. So I have a positive 10 equals negative 10. We can minus 10 on both sides. So we end up with 0 equals negative 20. Does 0 equal negative 20? It does not. So how many solutions would that be? No solution. Oopsies, I should spell it right. No solution. No solution. All right. For 3, what do we do when we have a number outside of parentheses? Distribute. Good. So 3 times x is 3x. 3 times 4 is 12. And then everything on the other side gets brought down. Nothing I can do on the other side yet. So what I want you to do now is solve that. We did this last week, so you should have no problem solving that. Welcome back. We should have subtracted 3x on both sides. That goes away. Actually, that goes away. So I have positive 12 equals, oopsies, positive 12. And again, at this point, we should know that 12 does equal 12, right? If you need to take a step further, that's fine. But that means that it's infinitely many solutions. They equal the same thing. All right? And then last but not least, I want you to solve number 4 and see what you get. There's nothing extra special. Just solve that one and see what you get. Welcome back. We should have subtracted 2x on both sides, giving us 3x. I had a plus 8 still. I had a negative 1 still. I'm going to move this 8 over to here, so minus 8 minus 8. So 3x equals negative 9 divided by 3. So x equals negative 3, which means 1 solution. 1 solution. Okay. Number 5 is very, very similar. Number 5 is very, very similar to the one up here. So we have Gil making 3 bracelets and Mika making 2 bracelets. They use the same number of string colors. How many colors should they use to make? So this is their 2 equations. This is Gil's, that's Mika's, and we're going to solve this, keeping in mind that this is very similar to how number 3 started. So what's that give us? 6x. What's that give us? 15. On this side, what's that give us? 6x. I need another color. What's that give us? 6. And then we go to solve it right. So what do you want to do on both sides? Move this over to here. So minus 6x. That cancels out. And actually that cancels out. So I have positive 15 equals positive 6. Does 15 equal 6? It does not. So this is no solution. So how many colors should they use to make the same amount of money? There's never a point where they will make the same amount of money. That's kind of what that means when we're talking about this in the context of a problem. Okay? So